Okay, this is Unit 1, Lesson 10, The Effect of Extremes. 10.1 says Battle Royale, and it says several video games are based on a genre called Battle Royale, in which 100 players are on an island and they fight until only one player remains and is crowned the winner. This type of game can often be played in solo mode as individuals or in team mode in groups of 2. Now, whenever I teach this lesson to my students and we go over this part, the first thing several of them usually say is Fortnite. So this makes them think of the game Fortnite because this is how it is. This is the way this game is set up. Okay, number 1 is saying what information would you use to determine the top players in each mode, solo and team? And then it says to explain your reasoning. So in the game, how would you determine those top players in each mode? Like what makes you decide this player is the top player? So write that down or type it and tell what you would do for that, what you would suggest for that top player. Number 2 says one person claims that the best solo players play Game A. Another person claims that Game B has better solo players. How could you display data to help inform their discussion? So how could you display the data in order to show, which one has better solo players? Well, there are different displays. You could possibly create a dot plot to display the number of other players defeated by those top 100 players in each game, and then you could compare those centers and variability of each distribution. So I'll give you some text to write here. But of course, you can always do your own words too. So you could say, I would create dot plots of the number of other players defeated by the top 100 players in each game. Once you display that, then you need to compare. And comparing these, you could say, you want to compare your measures of center and your measures of variability. So once you did this, then I would compare the center and variability of each distribution. All right, let's look at 10.2, separated by skew. So number 1 says use technology to create a dot plot that represents the distribution of the data, then describe the shape of the distribution. So we need to first create a dot plot. So I have our math tools over here and our spreadsheet. So we're going to type in this data and whoops, 13, 14. Make sure I've got them all. 18, so 3, 6, 7, 8, 9. Okay, it looks like that's what it is, and we have to create a dot plot. So you go to this histogram here, one variable analysis, and then you go here and click dot plot. So here is the dot plot. Okay, and this shape is symmetric. If I were to draw a line vertically down the center of this, I could fold it over on itself, and then the left and the right side would match up perfectly. So it is symmetric, and this is considered bell-shaped. This is considered the bell-shaped, and it is also symmetric. Okay, so the next thing they want, number 2, find the mean and median. So we can go here, and remember when we have symmetric data distribution, the mean and the median are equal. So look here, we have mean is 10, and we also have median is 10. So for this one, shape is, or we could say the distribution is bell-shaped. Distribution, bell-shaped, and symmetric. Oops. Okay. And then on this one, find the mean and the median. So mean is 10, and median is also 10. Number 3, find the mean and median of the data with 2 additional values included as described. So A says add 2 values to the original data set that are greater than 14. So we could just go here and add 15 and let's say 25. Okay, so we added 2 values, and they want us to tell the mean and the median. So go back here, and it looks like, I'm going to make sure, but it should be the same. Okay, so the mean is 11 and the median is 10. So let's go back and add our text box here. Mean 11. Oops. Okay, now it says for B, add 2 values to the original data set that are less than 6. So it says original, so I'm going to go here and I'm going to delete these because it says to original data set. So I'm going to say 0 and what? I'm going to say negative 20. Let's just see what happens. Okay, so I'm going to recalculate, and okay, so our mean is 8. 8. And median is 10. Okay, now C says add 1 value that is greater than 14 and 1 value that is less than 6 to the original data set. So let's go here and delete greater than 14. So let's add 50. And let's 1 value that is less than 6. Let's do negative 100. Okay, so we re-highlight one variable analysis, and all right, so it says mean is 6.5, median is 10. All right, D says add the 2 values 50 and 100 to the original data set. Well, we already have 50, so let's just change this one to positive 100 instead of negative. And go back. Okay, so our mean is 16.5 and median is 10. Now it says share your work with your group. What do you notice is happening with the mean and median based on the additional values? So look at what happened with the mean. Notice that the mean has changed every time, but the median has always stayed the same. Okay, so the mean, we could say that the mean changes depending on the values, but the median stays, or you could say remains 10 in each situation. Okay, 5 says change the value so that the distribution fits the description given to you by your teacher. Find the mean and median. So let's see, we could just say let's do a uniform distribution with data between 4 and 12. Okay, uniform, remember that they're all the same. So let's clear all this out. And a uniform distribution with data between 4 and 12. So we could say 4, 4, 4, 5, 5, 5, 6, 6, 7, 7, 8, 8, 8, 9. Whoops. Should be 9, 10, 10. Okay, and let's see what happens here. If we calculate this, there's a uniform distribution with data between 4 and 12. All right, so we did that. And then they want us to find the mean and the median. So the mean is 8 and the median is also 8. Okay, so let's do that. Mean 8, median is 8. Find another group that created a distribution with a different description. Explain your work and listen to their explanation, then compare your measures of center. All right, so let's look at Let's look at 10.3. It says create a possible dot plot with at least 10 values for each of the conditions listed. Each dot plot must have at least 3 values that are different. Okay, so I'm going to erase all of this. And let's see. So 1 says a distribution that has both mean and median of 10. So we could do this. We could do 7, 8, 9, 10. Okay, so let's see this happens. All right, so we have a dot plot and mean and median are both 10. So there, that's what it would look like. Okay, now it says a distribution that has both mean and median of negative 15. So on 1, you would draw your dot plot. On number 2, a distribution that has both mean and median of negative 15. So you could do this. Let's say negative 20, negative 20. Whoops. All right, let's see. So there's 10 values. Let's calculate. And median's negative 15, and so is the mean. I don't know why that's doing that. Negative 15 is the mean, and median's also negative 15. So you would draw your dot plot. You can use different numbers as long as you meet the conditions that are listed. Okay, number 3, a distribution that has a median of 2.5 and a mean greater than the median. So the median is 2.5, and we need the mean to be greater. So let's try this. Okay. So let's calculate. So the mean's 3.2 and the median's 2.5. So what happened was your median ended up falling in between 2 and 3. And so it ended up being 2.5. And then your mean is you add these all up and divide by 10, and your mean ends up being 3.2. So there's a dot plot for that, and you can see that is skewed, and so you can see that the mean is greater than the median. That would be skewed right. All right, look at number 4, a distribution that has a median of 5 and the median is greater than the mean. So this tells me probably needs to be skewed left. Most of the data needs to be on the right. So let's look at that. Okay. So let's calculate. And the mean has to be, or the median has to be 5, and the median has to be greater than the mean. So there we go. The median's 5, and the mean is 4.6. So you could draw your dot plot there. All right, so the lesson summary. Wait, let me see this real quick. Okay, so there are first 2 dot plots that we did for 1 and 2, where it had to be both mean and median were 10, and then both mean and median are negative 15. Those 2 dot plots were both symmetric, and the mean, we would choose mean as the more appropriate measure of center. The mean of a set of data gives equal importance to each value to find the center. So it is a preferred measure of center when it accurately represents typical values for data. So on the first 2, if you have a symmetric dot plot, the mean is the more appropriate measure of center. On what do the shapes of the dot plots have in common when the mean was greater than the mean? That was skewed right, and we talked about that. And then what information does the shape of the skewed distributions tell you about the median and mean? When distributions are skewed right, they will likely have a mean that is greater than the median, because the values to the right disproportionately impact the mean. When distributions are skewed left, they will likely have a mean that is less than the median, because the values to the left disproportionately impact the mean. So this one was skewed left, and we had the median was greater than the mean, or you could say the mean is less than the median. Now, if you want to write that down, you could pause and rewind this so that you could write those 2 discussion questions down and have those in your notes. All right, so looking at the lesson summary, here is some great information here. So you could go and highlight your, is it better to use the mean or the median to describe the center of a data set? And I'm not very good at this apparently. And the mean gives equal importance to each value when finding the center. And so here it's telling you when it's a symmetric distribution. But then also the mean can be greatly affected by changes to even a single value. The median tells you the middle value, so the changes to a single value doesn't always affect the median as much. So the median is more appropriate for data that is not very symmetric. So like skewed data set, is your median is going to be a better measure of center. So go on and read this, highlight or take notes on anything that's important in this. I have my students do that because I feel like that when they read and take notes or highlight, then it makes you remember it more. So I always have my students read and take notes over the summaries, or at least highlight or something. So this is it for Unit 1, Lesson 10.